All right, so today we're going to look at the binomial theorem. And basically we're going to learn how to use the binomial theorem a little bit. Start off with generating Pascal's triangle. So if you're familiar with Pascal's triangle, I'm just going to remind you on how to use it a little bit. So we can generate columns of Pascal's triangle. The first row of Pascal's triangle is row 0. And the first column of Pascal's triangle is also column 0. So this cell here would be 0, 0. 0, 0 is a 1. And then in the left-hand and right-hand corners, we always put a 1. So we have 1, 1 on the next row. But these middle pieces here are made by adding together the two that are above. So there's a 0 over here in effect. So that's where this one comes on. So let's see what the next row is. The next row, we always have a 1 at the ends here. And this is going to be made by going along these two rows here. So we have 1 plus 2 gives us a 3. This is going to be 2 plus 1 gives us a 3. This next row is going to be 1, and then we're going to get 4, 6, 4, 1. So the cells in this row, just zooming in a little bit, which row are we? We are in row 4. So this is going to be cell 4, 0, 4, 1, 4, 2, 4, 3, and the last one is going to be 4, 4. So we can reference the different cells in this one using this technique here. What will be the next row? What will be the next row? Row 5. What will the contents be? 1, 5, 10, 10, 5, 1. And then the last row. Somebody else want to help me with this last row? Anas. 1, 6, 15, 20, 15, 6, 1. What is the reference number for this one here? What is the reference number for this one here? Is it 6-4 or 6-5? Why is it 6-4 and not 6-5? We start with 0. We start with 0. Okay. Right. So this is how we get Pascal's triangle. So we have this question here, using Pascal's triangle, make this expansion. So the way we would do it is we would start off by expanding our Pascal's triangle and generating it for ourselves. And then counting 0, 1, 2, 3, 4, 5. All right, we've got the row that we need. We're going to use this one. It's the 5th row. We just do my row numbers over here. 0, 1, 2, 3, 4, 5. This is the 5th row. These numbers are 5, 0, 5, 1, 5, 2, 5, 3, 5, 4, and 5, 5. These are the numbers. I'll come back to that. So now we need to do our expansion. We've got x plus 2 to the power of 5. So it's going to work like this. I'm just going to use these numbers a little bit. So here's that number. And then I'm going to need, there's a pattern that's going to come up here. X to the 5, 2 to the 0. And then my next Pascal's number is 5. And I'm going to use x to the 4, 2 to the 1. Our next number is 10. That's going to be x to the 3 times 2 to the 2. Let me continue on the next row here. So I'm up to this one, 10. What? Help me out with this term. It's going to be 10 times what? X to the power of 2, and then 2 to the 3. And the next one? 5. X1, 2, 4. And the last one? 1. I'm going to put in the x0. And then 2, 5. So now I'm going to simplify all of this. So the first term is going to simply be x to the 5. The second term is going to be 10x to the 4. What will the third term be made by this bit here? What will the third term? 40x cubed. And the next term? Somebody else, Danny? Somebody else? What's the next one going to be? 80x squared. And then we're on that one. What's that one going to be? Remember, 16 times 5 is the same as 8 times 10. Yeah. 80x. And our last term, 2 to the 5, 32. So here is the expansion requested. So we need to know how to expand. One of the goals is how to expand using Pascal's triangle. So this expansion, and that's how we do it. There's some questions to practice of that one. Now, if we... Yeah. So these numbers, what we got here in this pattern is we see we get the combination number in front, so the n stays the same, and then the r at the bottom increases by 1 at a time until we get to n over n at the end. So it goes, in our last one it was 5 over 0, 5 over 1, 5 over 2, 3, 4, till we got 5 over 5. Look, those were the numbers that we were using. And this is how we reference Pascal's triangle, is with these combination numbers at the beginning. The first term in this one, this starts at that term to the power of n until we get down to that term to the power of 0. In our last one, that was x. It started as x to the 5 until we got to x to the 0. It goes x to the 5, x to the 4, 3, 2, 1, 0. So the x term, the first term, the a, that one counts down, and the other one counts up. So this term counts up. It starts at b to the 0, and then it's b to the 1 until we get to b to the n. And we have a little general form. This is the formula you want to memorize for Pascal, for binomial expansion, is this formula here. This lets us get straight to any particular term. In order to do that, without using Pascal's triangle, we want to be able to make those combination numbers. So we have a formula for the combination numbers, like this one, n over r. In the last one, it went 5, 0, 5, 1, 5, 2, 5, 3, and so on. So this is one of the ones from the one we just made. It's 5, 3. So 5, 3 is this one. 5, 3 is this one. How can we zoom straight in? We have a formula for it here using factorials. And we can see the formula there. Let me show you how to use this one. So we want the combination number 5, 3. That means we've got 5 factorial over 3 factorial times 5 minus 3 is 2, 2 factorial. What a factorial looks like is this: 5 times 4 times 3 times 2 times 1. And this is going to be over 3 times 2 times 1, and then multiplied by 2 times 1. But what's going to happen with these is this factorial here cancels a large part of that bit out. We ignore the ones. And we're left with 5 over 4, which is 5 times 2, which is 10. So this one here, we'll cancel that down to a 2. We've got 5 times 2. We've got 10. Just to show you how to do it, have a go at this one for yourself now, and then I'll show you how to do it. I'll leave it there. Take a minute to have a go at this one for yourself. Okay, so doing this one, according to the formula, I'm going to need 12 factorial over 10 factorial times 2 factorial. So write this as 12 times 11 times 10 factorial over 10 factorial times 2. The reason I do this is that's always going to cancel that. 10 factorial times 10 divided by 10 factorial. This 2, we can halve this one into a 6. So our answer is going to be 6 times 11, 66. Okay, so we are going to use these blue formulas. Let's have a go at what is the coefficient of the term containing x to the 4 in the expansion of x plus 5 to the power of 6. So if we use this formula, we've got, let me just put up what we've got. We know that n is equal to 6. We've got 6r times x to the n minus r times 5 to the r. This will be the term that we're after. We need to find out what r is going to be. What is r going to be? Well, we need x to the n minus r to equal x to the 4. Sorry, let me change my n. We know n is 6. 6 minus r, 6 to the r. What is the value of r? 2. So this tells us that r is equal to 2. So we need 6 2, the combination number, times 5 to the 2 times x to the 4. Now, what we're after is we're after the coefficient because of the way that the question is worded. The whole term would be what we've got here, but we're not going to need this part of the term. We've used that already because the question is asking for the coefficient. So the coefficient is going to be the combination number times by 25. So let's find the combination number next. So 2 is equal to 6 factorial, 2 factorial, 4 factorial. That's going to be 6 times 5 times, I'll take the 4 factorial because that's bigger than the 2 factorial, 2 times 4 factorial. These cancel. This simplifies this to a 3. And what have I got? I've got 15 times, I've got 15 for that. So the coefficient, our coefficient is going to be 15 times 25, which is, just work this one out, 15 times 25, 375 is the coefficient. So that term is going to be 375 x to the power of 4. Okay, so we've got the coefficient of the x, of the term containing x to the x cubed, and we need to find that one. So first up, what we need to do is we need to figure out what our r is. So we can see that n is going to be 8. So we also know that 8 minus r has to equal 3, which implies that r is equal to how much? 5. So we are going to want the combination number 8C5. We are going to want the combination number 8C5. So on the calculator, press menu probability. So you have a look on your calculator, and you can find this on the menu. Menu probability, and then number 3 combinations. Number 3 combinations. So to put it into the calculator, we're putting it in using the function and passing it the parameters. And you need to pass it 8, 5. So if we type in 8, 5 onto this one, press enter, we're going to get 56. So this is going to be 56. Then on our calculator, we need to figure out what 3 to the power of 5 is. Now be careful here. Notice it's not 3. What is the value of b inside the bracket? -3. And that's going to matter because 5 is an odd number, isn't it? So we are going to want, if you're doing this on your calculator, watch this. The calculator will get it wrong if you just type in -3 to the power of 5. It's going to give you, oh, it gives it right, sorry. If it's even, it would give you it wrong. So if I did -3 to the power of 4, I'm still going to get a negative. That's because in order to do these type on the calculator, we need the bracket first, and then we need to do to the power of. Doesn't matter when the result's going to come out negative, but it would matter for an even one. So let me show you for an even one. If we use 4, that would give me plus 81, which is the correct answer now. So take care when doing exponents of negatives on your calculator and add a bracket as shown there on the video. So we need to put this in. This is going to give us -243. So what we're going to need then on this one is we are going to need the product of those two. So I'll just scroll up. Let's take this one, enter, multiply it by this one, enter, and enter again. And I'm getting our coefficient is equal to -13608. So 13,608. So what have we got? We've got this one is -243. And our final answer is -13,608. All right, that's that one finished. Let's have a look at the next one. Exam style question. Let's have a go at this one. 2 minutes for this one. Okay, so we need Pascal's triangle to get started on this one. Just going to whiz it up a little bit quickly here. So we are going for the fourth row. 0, 1, 2, 3, fourth row. This is the row that we want. So we've got 1, 4, 6, 4, 1. We're also going to add in these numbers here. We are going to have 3 to the 1, 3 to the 2, 3 to the 3, 3 to the 4. Which of these products is going to be biggest? So this one is going to be, this is definitely not it, is it? It's 12. This one, 6 times 3 squared is equal to 2 times 3 cubed. Just move one of the 3's from the 6 into the second product. So our next one is going to be 4 times 3 cubed. And our last one is going to be 3 to the 4, which is 3 times 3 cubed. So I've got 2 times 3 cubed, 4 times 3 cubed, and 3 times 3 cubed. Which is the biggest? 4 times 3 cubed. Notice what I've done here is we just discount that one. But all of these, I've got this. So all I have to look at is 2, 3, or 4. C is the biggest. So I didn't actually do all arithmetic. I just moved some of the factors across because there were 3's in them, and was able to equate it and just say, look, yeah, that's definitely the biggest. So I did this without the calculator. All right. That's it for today. Homework is there's a worksheet on the Google Classroom for you guys.